All right, so this is going to just be a real quick demo of how to use a computational tool for direction fields. So I'm at Google. I've just typed in D field. Oh, sorry, I said its name and it popped up on my phone. So I've typed in D field, hit enter, and I opened both of these sites before checking that that's the right thing to Google. This first one at unm.edu lets you download this tool if that's something that's of interest to you. And this one at uark.edu is actually what I'm going to use here. And I'll post a link to it on Blackboard for you. But it tells you that it plots for dy dx equal to f of xy right here, the direction field, and it tells you you can download a better one. And what we're going to do is we're just going to look at the exact same one we just drew so that you can kind of see how to use this tool. It's not that hard. So for whatever reason, the entire website is written in terms of t and y, but it'll accept x as an input. So it says dy dt is equal to, and I'm just going to use our same one, dy dt is equal, or dy dx is equal to 0.2 times x times y. If you wanted to put t here, that would be fine too. X and t are the same thing for this conversation. Importantly, just make sure that you put star signs for multiplication, and it says right here like sine of x, not sine x. I won't know what that means. And then you can change like the view of it. So we'll mess with that in a second. But you just hit graph and this picture looks like what I was drawing was supposed to look like. And if you click anywhere on this plot, what's going to happen is it'll plot for you the solution that goes through that point. So all these little arrows are that direction field we spent all that time talking about drawing. Steep as you have moved away from the origin. Oh, you probably can't see me pointing with my mouse. Sorry. And then 0-ish over here close to the origin. And anywhere you click, it'll just generate a new solution. So somebody says, what does dy dx equal to 0.2 xy with initial condition y of -1 is equal to -4 look like? You would click right here at -1, -4, and you would say, oh, it's that little upside down parabola. If you need to expand this, you can change it to have wider ranges. For this particular direction field, it's not going to look very interesting to do that, but just so you know, now we're looking at -10 to 10. You have much steeper arrows everywhere, but same behavior. And that's how you use this tool. We're going to get like a chance to work with this when you do your projects. So I just wanted to make sure that everyone understood how to use it. Just so you can see that t works the exact same way. When I type in t for x, everything's the same. So the important things for using this tool are use the star sign for multiplication. Make sure that y is your dependent variable and x or t is your independent variable. I'll type that here. That way you can just see it. That's the only trick to using this. So keep this in mind for when we're working on our projects. In the next video, we're going to finally get around to looking at equilibrium values.